Exactly. Oh, is this our notes?
Okay, attention up here, please. So your notes are on the other side. For anybody who does not have a notes page.
I don't know if he does.
Go up and get it. You're welcome. So I'm not going to come to you. Come up and get it, please. So when we have the numbers 1, 2, 3, dot, dot, dot. What does the dot, dot, dot mean?
So on.
And even more specifically with math, what does it mean in this situation? Infinity.
Oh.
Yes, and how are we going to infinity? Going anywhere to infinity, or?
These are whole numbers.
By 1.
So I love that. That's what we'd be asking. So, but they are the same pattern, right? Up to infinity. What is the name of these numbers that start with 1 and keep going up by 1 up to infinity? No. What did you say, Yusuf?
Whole numbers.
Whole numbers. Okay, if I add 0, I've got a circle here, and these numbers include the 1, 2, 3, dot, dot, dot. 1, 2, 3 going on forever. So what would that name and numbers be if I add 0 there? I'm sorry, this is not whole numbers, my bad. Starts with an N. Anybody know what it is? Natural, that's right. And this is whole numbers. My bad, sorry about that. And then if we add, -1, -2, -3, dot, 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 to negative infinity, what's the name of those numbers?
Negative numbers.
No, we have a more specific name. You're right, they're negative. Sorry.
What's the first letter?
Was it like
I.
integers? Yeah, integers.
Integers, that's right. So these are integers. So now, if I add, say, here's some examples. Any number that can be written as a ratio of 2 integers. So, for example, 3/4, -11/9, 8.3 with the 3 repeating. Anybody know what those numbers are called? Not yet. They're going to come up. It does start with an R.
Ratio.
Rational numbers. That's right. So these are rational numbers. Again, we can write them as a ratio of 2 integers. So for example, 2 can be written as a ratio of 2 integers. That would be 2 over, what would we put on the bottom of the 2 to make it a ratio of 2 integers? 2 over 1, that's right. Okay, so now, in this other box over here, I'm going to put the square root of 5. I'm going to put pi. These, again, are examples. And then I'm going to put 1.4, negative 1.4713 with no pattern. So it's a decimal that does not have a pattern.
Do we have homework this week? So how many points is it worth? You just like.
So ask me later.
Oh, okay.
So what is the name of these numbers?
Oh, irrational.
Irrational, that's right.
No.
So these are irrational numbers. So they're numbers that can't be written as a ratio of 2 integers.
Circle imaginary numbers.
And so this big box here that includes both the rational and the irrational, those words, those are called, it starts with an R.
Oh, real numbers.
Real numbers. So these make up the real numbers, irrational and real. And then this circle over here, yes, Kobe, you were right. We are talking about square root of, say, -3. So these would be imaginary numbers. Yep. Talked about it last Wednesday. So now what's new today is we're going to talk about complex numbers today. So complex numbers would be a number like 3 minus 7i. So it has a real part and an imaginary part. We'll talk a little bit more about that. So down on the bottom of this, we have complex numbers. Anybody still looking at this here? So complex numbers, we write as a plus bi. So a is the real part, and b is the imaginary part. A plus bi, where we have the number and then the number in front of the I, is standard form. And you want to write them in standard form. Put the real part first and the imaginary part second. Okay, so what we're going to do today is we're going to add, subtract, and multiply complex numbers. Anybody still looking at this? Okay. So let's do the first one, the negative I plus 4i. So what we're going to do when we add them, we're going to add just like we would if we were adding expressions. So same thing as if this were negative x plus 4x. We just add those coefficients, the numbers in the front. So that negative 1 plus 4 adds to 3. So it's going to be 3i. That's right.
Wait, what?
You just add the coefficients. Just like if there's an x there, it's the same. You do the same thing. So what would number 2 equal? You guys, if you want to buy some pens from me, keep going with that. So what is that? What is this one give us? So he got negative 8i. How did he get that? He added negative 6 plus 3 minus 5. And that adds to negative 8. And so it would be negative 8i. Does that make sense?
Oh, okay, I see what you're doing.
Oh, I
Okay, so number 3 is different. You want to add the like parts. So your like parts here would be in the 4 and the 5. What does 4 plus 5 add up to? 9. And then these are the like parts also. 7i minus 3i. What would that add up to, Will?
What? Oh, 4i.
Yeah, so 9 plus 4i. Does that make sense?
Yeah.
Now, I want to write this with a 9 first because why? Yes, JJ? That's right, standard form. Yes, you said.
How do you know if you're not supposed to foil it? Because isn't this like when you look at this equation at first, you think you foil it, but the thing is.
Very good question. He's talking about a very, very common mistake. So how do we know we're not supposed to foil here? How do we know we're not multiplying?
Because it's a plus.
That's right. This sign there is a plus. If there was nothing in between, then that would be multiplication.
So
They've got to be closer, though.
is it the same? So is it the same case to a negative? Like a negative, you distribute the negative into the next thing.
So we're going to do a negative on the next one. So on the next one, we have a minus. So when we have that minus, just like we did when we had expressions. So we're going to distribute, this is like plus a negative 1. We're going to distribute this negative 1. So we get negative 7 plus 4i, and then negative 1 times negative 4 is positive 4. Thank you, those of you that are sitting quietly. Multiply by negative 4. We're distributing this negative 1. Negative 1 times negative 8i is positive 8i. I recommend that you rewrite it when you have to distribute that negative 1. Now we're going to add our like terms. What would this add up to when we add our like terms? Somebody in this group here. Good. So negative 3 plus 12i. So these would be our like terms on this one. Does that make sense?
Yeah.
So the only time I distribute that negative is if there's a minus in the front. There was no minus in the front of this one. It was plus, so I didn't do any distributing. So now I want to distribute the negative here, and I want to distribute the negative here. Again, I recommend rewriting. In my other classes, if the students didn't rewrite, frequently they got it wrong. So 5 plus 5i, and then when we distribute the negative 1, what do we get here when we distribute this negative 1? Somebody from this group.
Us?
Yeah. Positive 3, good. Good. And then go ahead and distribute the negative 1 on this one.
Plus 2.
Plus 2.
Plus I.
Plus I. And then we're going to add our like terms. And that would add to 10. And 9i plus 9i. Okay, go ahead and do the U try, please.
That's a question.
Yes.
On a quiz, we really mark down if we like didn't show our work. Like not. Genuinely, would we? There's no such thing as a bad question. It's like, what if you like? Because I've had teachers who mark me down, like in trades, Mr. Sweet would mark us down if we didn't show. No, but I mean for this, because you can like do mental half of it. So. Okay. Yeah.
Check, so go ahead and do this number 6.
It's like bro.
I'm coming around and checking your number 6.
Exactly. Wait, whose lead's in that pencil? Whose lead's in that pencil? Whose lead is in that pencil?
I don't know how to combine my
And that was just where would you get Billy?
That is not right. I wasn't the one. No, children's hard stuff. You learn to do something. So I first quarter. And I just stopped taking out the test. I got that. I remember back home.
I don't think John.
No, you were in coding class. Actually, you can see it.
Hey, lady, look at me now.
like white bread.
Hey, look at me now.
My class, our class is more. It's all freshmen.
So now. I don't know how this like how we can be like they have fucking CX. It looks really what it said. God, what the fuck is that?
Hey, Go, how are you feeling now?
I'm feeling good a lot.
Saturday. How are you feeling on Monday morning?
It
was pretty fucked up.
It was bad. I was gonna go.
I know you were in the garage. I saw you be garage the entire time.
No, I came out for 30 minutes. I didn't back there.
Look at some minutes. I did not expect that many people. I can't lie. I thought it was like, I think this would be a real party. I thought it was going to be a real party.
What's the game?
I don't know. Negative 20 minus 79.
It's happy and unhappy. Yeah. I don't know.
The only mistakes I got was sometimes students wanted to change when you don't need to change. If it's positive already in the front, you don't change. So you don't change anything on this -6 minus 5i. It's only on this one that you change. Make that a -8 and a -4i. This one you don't change because it's a positive in the front. So this would be your answer. -20 minus 17i. Okay, lastly, multiplication.
Oh.
So multiplication is going to be the hardest. If we multiply square root 5 times square root 5, what do we get? I love how you said 5. A lot of times students will have a step in between there and they will get, what would they get? Square root of 25 to get 5. So Derek, when he did that, he went straight from here to the answer. That's what you're going to want to do when you multiply with complex numbers. You cannot use the same rule that we use on that one. This rule here is no longer pertinent. That middle rule is no longer pertinent. So when we have an I times an I, this is square root -1 times square root -1. See how these two numbers are the same? This is equal to 5. This is defined to be -1. We cannot rewrite this as square root -1 times -1. You have to skip that middle step. This is equal to -1. Yes, Yusuf?
I know you kind of already went over a little bit, but like, isn't there rules of i's that go up to 4? Like, one I, like for example,
There is, but I'm not going to do it.
When do we learn that?
I'm not going to do it.
Okay.
So if we have the square root of I times I times I, we have 3 of them. And so these two here, what does this give us? Square root of -1 times square root of -1 is -1. And then this square root -1, Cohen. So this is -1 times I or -I. So that's what Yusuf was referring to. There it goes to different patterns, but we're not going to talk about that in here. We just don't have time. So if we took 2i times 5i, 2 times 5 is 10. And then we have the square root of -1 times square root -1. Somebody over here in this room, what is the square root of -1 times square root of -1?
I -1.
The square root of -1 times square root of -1 is -1. So this is equal to 10 times -1 or -10. Does that make sense?
Yeah.
So this, I know it's a little bit kind of like mind-blowing a little bit. I'm going to skip 10, and then I want you to do number 11. And then I'll come around and check that.
I think you realize the phrase, right? I give you like a